Thanks for the opportunity to speak. That was a great talk. And I'm going to talk a little bit about the platform. Delisha talked about some of the outcomes of the platform that San Leandro has created. And it's great to be here. San Leandro was one of our charter members of US Ignite when we were formed, so we're thrilled. As you probably have heard, US Ignite's a nonprofit organization focused on generating new applications that run on gigabit fiber networks like you have here in San Leandro. We're a nonprofit focused on 6 sectors, so we're not just generating new apps for the sake of apps, but for solving solutions, providing solutions in education, healthcare, transportation, advanced manufacturing, and other clean energy, other sectors. We were founded about 2 years ago with inspiration from the National Science Foundation and the White House Office of Science and Technology Policy, who saw that it's a competitive necessity that U.S. cities take advantage of networks like this. We're focused on what we call next generation apps, which are apps that take advantage of faster speeds, like gigabit speeds, take advantage of local storage and computing capabilities to avoid some of the hops that you have to undergo at the traditional internet, and to take advantage of what's called software-defined networking, enabling the network to be shaped for the benefit of an application. We're aiming to create applications that run on 200 community testbeds like San Leandro, and share the best practices across those platforms. We've got many partners. It's a classic public-private partnership with members from the corporate world as well as from the cities, as well as research and education networks across the country, and a number of universities as well. This is a new world we're all embarking on, as Delisha made very clear when he talked about some of the things going on in China. And this is a platform that can enable us to take advantage of opportunities that otherwise would not be available to any of us. Just real quickly on the strategy, we form teams of public-private partnerships. We try to find opportunities to solve community problems, whether it's in civic engagement, healthcare, transportation, and we found that in cities like San Leandro, Kansas City, Chattanooga, Burlington, Vermont, Flint, Michigan, you can create ecosystems, perhaps not as dynamic yet as some of the ones Delisha was talking about, but you can create ecosystems built around this platform, and jobs are created and new core capabilities are created. And I found some of the same things Delisha mentioned, which is that you bring capabilities from universities, kind of unlocking university capabilities for the benefit of the city if you make known what you can do with a gigabit network. We have created a number of applications reaching out to developers, but a lot of them come from the university community. Some are funded by National Science Foundation. We've run a program called Mozilla Ignite, which generated dozens and dozens of new applications, and we come up with some of our own. But it's been fun to watch the developments occur. Google Development Group's been involved as well. We recently launched, in partnership with Mozilla, an exchange so that if you go to our website, you can find over 60 next-generation applications. It's an exchange in the sense that developers who have new apps are finding communities that want what they provide, and communities that are looking for new apps can go and find what new developers have created. We've also recently launched what's called a Global City Teams Challenge with NIST. It's the National Institutes of Standards and Technology, which is really focused on the Internet of Things. And we've created about 27 action clusters built all around many different types of solutions. And any of you who are interested should look at the website and see if you'd like to join one of those 27 action teams, because they're all looking for partners, whether it's corporate, civic, or nonprofit. And they've just started up, and there has recently been a National Science Foundation so-called Dear Colleague letter to fund some of those teams. And I wanted to give a little bit of perspective on our perspective on Internet of Things. It's sometimes called cyber physical systems in the government. I'm not sure exactly, but anyway, they're the same thing. But what we find is that sensors have been around. They've been, obviously, products and services have been enabled with sensors along with the physical properties of a product. Storage and compute capabilities have been around for a while. But what's new are the low latency gigabit networks connecting all of that together. And it's truly a revolution. And you kind of know it's a revolution when the Harvard Business Review and Michael Porter, who is the guru of global strategy, gets involved. There's a new article out this month that talks about Internet of Things bringing the third wave of IT competitive advantage. He started off with productivity in the 60s and 70s, and then the internet in the 80s and 90s, and now Internet of Things is enabling you to do things with products and services you could not do, such as monitoring the product's capabilities, There's a glucometer from Medtronics now that enables people with diabetes to be able to tell when they're reaching a threshold of glucose levels and need new glucose. And there's a control of the products. Wind turbines are able to control down to the individual blade and make sure that that's matching up with blades next to it. You're optimizing the product capabilities. And finally, eventually we'll have more and more autonomy for products and services so that the products are self-diagnosing problems. Farm systems, for example, are all over this. And they're taking advantage of the combination of monitoring, control, optimization, and autonomy capabilities, the Internet of Things, which is basically sensors or processors in a product or service connected to a cloud via a fast and improved network. This is a third wave, and it's going to be bigger than the first two waves, according to our experts at Harvard Business Review. We've seen one killer app come out at Chattanooga, which has 170,000 homes and businesses connected to a gigabit network. They've also have a smart network, smart grid, and they found that the smart grid has enabled the EPB, or the Electric Power Board, to reduce its duration of power outages by 60%, which has basically saved over $60 million, also saved about 350,000 miles of truck rolls that otherwise would have had required manual observation of where the outages have occurred. Let me just talk a little bit about, so that's kind of our point of view on the Internet of Things, and I'm sorry if I'm going a little too fast. I'd love to talk to you as we have time after this. But more broadly, the applications we're coming up with are trying to correct some of the deficiencies in today's Internet and solve problems in these sectors I've mentioned, like healthcare. As you know, there are lots of reasons why today's Internet is not the Internet we want. It's not as interactive or responsive as we wanted, and it suffers from what's called the tragedy of the commons, where all of us are trying to do what's best for our own interests, which may overall hurt all of us. And that's kind of the way the Internet has been built, with a packet as a packet, where everyone gets the same performance. And it looks very much like this, where you've got many homes and businesses have 10 megabits per second to the home, and you've got 8 or 10 hops from where you are to where you want to be. We're finding in a number of communities that if you put a gig from there to the school or business or the home, you get some improvement because you don't have to have the limitations of the last mile, and you can accomplish many things you couldn't otherwise accomplish. But more importantly, we're finding if you bring storage and computing power closer to the end user, you avoid some of the hops that make the Internet less responsive than you'd like it. And National Science Foundation has funded a program called GENIE, the Global Environment for Network Innovations, and they've put these GENIE racks in over 60 universities to explore what they call locavore computing, and we have been putting GENIE racks in a number of cities. We have a proposal going into National Science Foundation to fund over 25 cities with a locavore computing capability close to home. And I think San Leandro probably has that, given all the 3D examples I saw in your beautiful video. There's also another trend, which I won't get into too much, called software-defined networking, which basically takes what is a commodity Internet and sets up different channels so that you could have a health channel from a provider to the home, so that you as the resident at home or business could set up a 1-hour meeting with your doctor where you have specified speeds of a gigabit speed with a very low latency and with high security. And you could set that up for a specific time. Same thing, you could have a gaming channel where you get burst of speeds, and you're controlling that as opposed to having the carrier control that completely on an undiscriminated basis. But anyway, there are things like locavore computing that I've touched on, gigabit speeds, and customized applications that are solving some of the limitations of today's Internet. This is kind of the map we work in. It's basically a log scale. Each little unit there moves up by a factor of 10, but across the bottom it's the amount of data, and along the top it's the speed at which the data. So you think in terms of gigabits per second. So it's bits across the bottom and seconds on the axis, the vertical axis. And what you can do, if you move from that 10 megabits per second line over toward the gigabit line, you can get a lot more data at the same speed. Or you can move down and you can get the same amount of data. You can get more data but faster, okay? And what we do, we find applications, and we're populating applications throughout this map because we're finding that it's exactly a great way to illustrate what we're trying to show. Let me talk a little bit about the characteristics of applications that communities are finding when they have a gigabit platform with a locavore computing capability and maybe some software-defined networking thrown in. Extremely instantaneous, real-time capabilities, low latency, meaning there's no time between when you push a button and your data comes back. Extremely reliable. Internet of Things or cyber-physical interactions are important. Big data to the end user, real easy data exploration of multiple layers of data on a framework or a map of a landscape, real collaborative and very distributed, so you can have two engineers working in two different facilities at the same time working on a model without having any kind of delay. So these are the kind of characteristics we find. We have a large pipeline and we're always looking for new ideas. One of the things that's nice about this marketplace is that there are not a lot of big companies yet. It's so new that there are entrepreneurial opportunities that we're encouraging entrepreneurs in every city where we work to take advantage of. And I'll just give you a flip through. There's the Pew Internet and American Life project just came out with a list of killer apps for the future. And one of them has to be connected collaboration. Instead of having very expensive collaboration, if you have a gigabit network, you can have very low cost, instantaneous conversations with your doctor, as if you were there. And this is going to be extremely important given the Affordable Care Act mandates that we try to keep people from going back into emergency rooms when they don't have to. But that's going to be probably the most important killer app, is removing time and place so that people can get together. Similarly, immersive learning. When you have this localized compute and store capability, you can teach students how to manage a Mars lander by putting them on Mars with the lander and the controls. We're working with one city to teach what earthquakes, why fracking is a potential problem and why it may be good and bad, but sort of showing the balanced view of fracking by immersing students in the earth. And they can see what probabilities there are of causing an earthquake. And it really makes learning, problem-based learning, very much real. This is going to be a huge set of applications. Planet Impact. This is an application that came out of Kansas City's Google Fiber deployment. And it's basically a tool, again, immersive, 3D, for assessing what happens if we put in another building. What impact does that building have on runoff, jobs, economic impact? And it's really a very interactive modeling, simulation model for evaluating the impact of different decisions on the sustainability of a city. Public apps. When you have a gigabit fiber network and a local cloud and storage computing capability, libraries have been setting up software lending capabilities. Many students leave school and can't afford an SPSS or a Photoshop Pro, but if you set up a lending system, you can actually set it up so they borrow it for 2 hours at a time and in their homes. Virtually, you've probably seen some of these kind of CPU as a service or GPU as a service, where if you have a supercomputer available, you can basically, with a gigabit network, you can create the approximate capability that a supercomputer brings by using everyone's computer in this community. You can imagine a time when you could evaluate your own genomic makeup from your home if you have enough computing capability in town and a big enough connection. Remote radiology. Imagine a doctor radiologist being able to review X-rays from his home at midnight if you're in the operating room or emergency room needing to see what diagnosis is made. The doctor can do it instantaneously from home, and perhaps in a life-threatening situation. Remote surgery. Today this pertains more to remote surgical training. So you've got doctors who've done one, like a Da Vinci surgery, doctors who've done thousands of them, coaching doctors maybe done hundreds of them or tens of them. It's a great way. Or imagine a doctor going in to do your own surgery after practicing on a 3D image of your body in advance. This is important for San Leandro. With a reliable network brought about through software-defined networking, you can have much higher reliability and process control across manufacturing centers of a company, as well as much more collaborative design. Imagine designing a car from multiple spots. Some of this happens today across companies, but this is enabling people to do these kinds of activities from their homes or small businesses. Casa Radar is an NSF-funded project which is enabling communities in Dallas to evaluate weather down to the block level. It's low-level radar. Today's radar misses huge parts of the globe because of the curvature of the globe, but this enables radar to come down to a very low level. And finally, SimCenter, something in Chattanooga, which is helping the city evaluate potential disaster scenarios and respond quickly, so that if there's a chlorine cloud, it enables the city public safety officials to tell people where to go and where not to go, and then respond quickly. Anyway, there's a lot happening. We'd love to have more members of US Ignite. If there are people from Berkeley here or San Francisco, we'd love to talk to you about joining, because I think it's good. It's a good way to help create a more responsive ecosystem. And I'd love to just touch on some of the things going on. There's different Chattanooga, Kansas City, some certain characteristics that we've found as a way to take advantage of this new kind of network. And one of them is assembling an accelerator team that's broad-based. It's kind of like what San Leandro has done. It's enhancing the community infrastructure, trying to get gigabit fiber to the end user if you can. And then it's creating a constant stream of entrepreneurial activities like San Leandro has done. And there's no substitute for this. Dynamic ecosystems are created out of events like this, with a platform, with a physical space. And then what we do is connect cities to cities, so the best practices in Kansas City can be shared with San Leandro and Burlington. And then finally, leveraging federal partnerships. We try to find sources of funding. I mentioned the National Science Foundation is funding some projects, Internet of Things, and we're busy preparing a proposal to link, as I said, 25 cities with gigabit fiber. So I'd love to talk to you further about any of the elements I've come through. I appreciate your time today. I've gone through it a little bit fast, but there are great things happening. I think San Leandro is extremely well positioned to take advantage of what is a unique platform to take advantage of these kind of things. Thank you very much.